Hello, math fans. All right, what we are going to do now is actually graph polar coordinates. All right, now the important thing to understand about polar coordinates is a polar coordinate is not a complex number. So that's really important. So let's just write that out here. This is me graphing polar coordinates. Not complex numbers. Because we've been plotting on the real axis and imaginary axis. Well, a coordinate is this. It's r comma theta. Okay, that's a polar coordinate. And r represents your radius. And theta is basically your angle. And it's an angle basically counterclockwise. From the positive x-axis. So this is what a polar graph looks like. Okay, it's a little rough sketch there. Actually, it's really a rough sketch. Okay, but basically, let's just do an example here. If I said 2 comma 45 degrees, you always, this is important, you always do this first. You do your angle first, and you do your r value last. It's really important. So what I'm going to do is I'm going to go to 45 degrees, which is really on this line here. Okay, then I'm going to go out 2. So 1, 2. And so that is my polar coordinate right there. It's really simple. It's real simple. Okay, so if I said, 4 comma 180 degrees. Well, 180 is over here. It's on kind of like on the negative x-axis, but I'm just going to go 1, 2, 3, 4, and that's coordinate. That's 4 comma 180. All right. It's pretty easy. The only thing that gets a little tricky is this. Let me make a nice graph here again. And what if I said r was negative? Negative 2 comma 45 degrees. You need to realize that I always told you this is first. So you're going to go to 45 degrees here. But then the r is negative. That just means you go the other way. So instead of going out this way, towards the upper right, you're going to go down to the left. And if you want, you can just extend this line here. Because that's all it is. And then it's 45 degrees this way, so that means I go back the other way, and here is negative 2 comma 45 degrees. All right? That's really not that bad. And here, let's do another one here. Negative 3 comma 90 degrees. Well, that means I go, here's 90 degrees, this is the positive y-axis, and so I go to that angle first, and then it's negative 3, so then I go the other way. 1, 2, 3. And that's that guy right there, and that's this one here. Okay, so that's how you deal with negative r values. All right, that's not too bad. If I ask you to give me another value, let's say I give you 2 comma 45 degrees, and I said give me another coordinate that represents 2 comma 45. Well, remember, I guess I can sketch this real quickly again. 2 comma 45 is here. Well, isn't that the same thing as going all the way around here to 225, but then going back negative 2? So there we go. It's equal to negative 2 comma 225 degrees. Now, how did I do that mathematically? I did it graphically, but mathematically, if you look at it, I just added 180 degrees. And I can also say 2 comma, and remember 45 degrees, I can keep adding 360 degrees. I can keep doing coterminal. So if I add 360 to that, that's equal to 405 degrees. And if you notice, to go from here to here, you also added 180 degrees. So 180 plus 225 is 405. All right, so it's pretty easy to come up with a variety of answers. You either add, if you add 180 degrees, then what you're going to do is you're going to change the sign of R. And if you add 360 degrees, then the sign of R is the same. It's just coterminal. So you can keep adding. I can add another 180 to this, right? Then that would give me -2, 595 or 585 degrees. Right, and actually these two values right here, this guy and this guy, it's basically a difference of 360 because they're coterminal. Okay, so that's how you can deal with positive and negative values. If I give you a rectangular coordinate, so given a rectangular coordinate, and I want you to convert to polar coordinate. All right, that's pretty easy. It's 2, -2. So that's a rectangular coordinate. And the deal here, guys, is you got to graph it. Okay, so 2, -2 is right down here. So if I draw my triangle, this is 2, -2. And it's always going to be a 30, 60, 90 or 45, 45, 90. In this case here, it's 45, 45, 90. So this is 45 degrees here. So that's 2, 2. That means this is going to be 2 root 2. All right, and remember, theta is this distance around here. So your R is that 2 root 2. And your theta is, right, 360 minus 45, or 315 degrees. So your answer to this problem is 2 root 2, 315 degrees. Pretty simple. All right, and of course, what is that equal to? That's another. What if I say -2 root 2? That's equal to what? Well, I could subtract 180 from that too, right? So that's equal to 135 degrees, just to kind of give you a little sample of what it could be. Okay, so that's converting from rectangular to polar, and I can do polar to rectangular too also, right? So if I give you a polar of -2, 135 degrees, personally what I would do is I would get rid of that negative. Okay, it's just more complicated when you have a negative, and I would say that's equal to 2, and then I'd add 180 to that, and you get 315 degrees. So that is that's your polar. And then what I would do with that is you can make a quick sketch here. It's not a bad thought. 315 degrees. You know your reference angle is 45 degrees, kind of like the last problem. And your R is 2. And then you could just get your other values here, right? That, remember, it's x root 2 equals 2. And so I divide both sides by root 2. So x equals, and rationalize 2 root 2 over 2. And that's just the same thing as root 2. So these guys are root 2, and that's root 2. Of course, that's negative, and that's all I need. I need my x and y value. So the answer to this problem is root 2, negative root 2. Okay? Not too bad, right? All right, so that's it, math fans. Hope you learned a little bit just about polar coordinates.